Beep. Mr. H, you're wearing the same clothes as yesterday. No. I actually change my clothes every day. My mommy taught me very young, always have to have fresh undies. So, did I change clothes from yesterday? Yes, I've changed clothes from yesterday, but it's still June 9th. I'm still doing all of these videos at the same time because I want to make sure that if something I don't like is there, I can adjust it throughout the entire summer. I really hope that everything this year goes very, very smoothly, which is why I'm spending so much time during the summer. So, lesson 2, grade 8, module 1, lesson 2, have yourself a piece of paper out. Today, we are talking about multiplication of numbers. The key here, what I want you to write above this, is bases must be the same. Okay, I'm going to talk about that a lot. The bases must be the same. So perhaps on a separate piece of paper, it's good to write down this example. If I've got 2 to the third multiplied by 2 to the fourth, and I want to keep it in exponential form, I can simplify this without actually simplifying it. Okay? So, what do I need to do? What we learned in the last lesson was 2 to the third means 2 times 2 times 2 times 2 to the fourth, which is 2 times 2 times 2 times 2. Well, we know exponential form is the base, how many times. So just like your homework that we just went over, this is how many times. Well, this is 1, 2, 3, 4, 5, 6, 7. This is 7 times. So this is really 2 to the 7th. How could I have gotten 2 to the 7th? Well, let's think about this. If there were 3 2's here, 4 2's here, I really took the 3 plus the 4 and got 7. We're keeping the base the same, but adding the exponents. And that's what we're talking about. So, that's a real life example, and then they try to discuss it down here. So, let's take a look. It says, and this is something that perhaps I'd have a highlighter out, and I would highlight. If x is any number and m and n are positive integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and on and on and on. Integers, remember, there are counting numbers and their opposites, but because it's positive, it's really saying, and what they should have said, was natural numbers. So, x to the m, let's give it any value, 7. Give n any value, 10. That would be 7 plus 10, which then I can take the next step and add them together. So if m was 7, n was 10, then I would have x equals x to the 17th. But they don't have numbers there. Because it's m times, n times, we add them together. So come on down here, we're going to do a couple different things. So let's rock out exercise 1. First off, are the bases the same? That's the key. Listen, 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 listen. If the bases are not the same, don't waste your time. Okay? You're going to actually have to do math if that's the case. Right now we can just stick to like basic stuff. 14 times 14 times 14 times 23 times. 14 times 14 8 times. Well, that really means we're keeping the base. We're taking this one exponent and we're adding it to the next exponent. Why? Because there's 23 14s plus another 8 14s, which then gives me 14 to the 31st. Engage New York doesn't want us to go to this step, and I don't understand why. Go to this step. Simplify it down in exponential notation. Do not leave it like this for me. Understood? Nod? Perfect. Okay. Try exercise. Wait, I've got them all marked down. Try exercise. Yeah, let's do exercise 2. Do exercise 7 and do exercise 8. I know it's not on the board yet, but do exercise 8 on your packet too. So pause, try those. I'm going to move this down a little bit, so as you come unpaused, you should be able to see exercise 2, exercise 7, and exercise 8. We know the bases are the same. Oh, but they're negative, so I need to keep that in my parentheses. Absolutely, great job. I know that I'm taking 10 plus 13. Do I have to show that, Mr. H? No, because we know that when we add those, that gives me 23. The only reason why I would suggest you showing that is if some unbeknownst reason you are bad with your calculator and can't add 10 plus 13, at least I know you understand the process and you just screwed up your addition. Exercise 6. Not exercise 6. Exercise 7. Ooh, B be a number. So we don't know what B is. We know it's a variable. It's going to take the place of a number. We keep B. Then we're doing 94 plus 78. Oh my gosh, it's the summer, and I'm not intact with that. 8 plus 4 is 12. Regroup to 1. 8 plus 9 is 17. So I get B to the 172nd. I'm checking the math. It's not there because it stinks. Okay. Last but not least, let x be a positive integer. Okay, now, this is more like an equation. We're solving for this missing variable of x. We know that 9, and here's how I would do this. My math brain works like this. Negative 3 to the 9 multiplied by negative 3 to the x equals negative 3 to the 14th. Well, I know that negative 3 is 9 plus something, and that has to equal negative 3 to the 14th. Well, the base stays, so really my equation says 9 plus x equals 14. Do I know how to solve simple one-step equations? Sure. I subtract 9 from both sides. That leaves me with x equaling 5. So I can say that that should be negative 3 to the 5th. If you have any questions on that, by all means, certainly ask. Okay. A couple more examples and then time for your homework. What would happen if they were the same base? Okay, you're on your own. Do exercise 9. Do exercise 10. Do exercise 11, do exercise 12. Unpause me once you've gotten those. Okay. Are the bases the same? Yep. Keep the base. Add the exponents. So that really gives me 9, 10 plus 13 is 23. It does not matter how many terms you have as long as the base is the same. So I've got 2, 3 plus 5 plus 7 plus 9 equals 2 to the 8 plus 7 is 15 plus 9 is the 24th. 2 to the 24th. This guy, okay. Problems. We've got a 6 and a 6, and we've got 2 4s. So we can't combine them all. But listen, we can combine the like bases. So 4, 9 plus 3, multiplied by, because we're multiplying, 6, 5 plus 14. So in essence, that's 4 to the 12th multiplied by 6 to the 19th. Same thing down here. Oof, it's a long way down. Negative 4 to the 2 plus 3 is 5, multiplied by 17 to the 5 plus 7 is 12. So I skipped the step where I had to add. Why? Because I'm a good adder. I'm good at this. Questions there? Okay. Couple trickier ones, but I can't express how important these next ones are. Okay. Rewrite this in simpler form. This is a multiplication question. This says all of this multiplied by all of that. Well, let's find like terms that we can actually multiply. We can multiply 2 and 17. Why are those like terms? Because those are just our coefficients. Remember, we can combine our coefficients, especially in multiplication. So that's 34. X to the 3rd multiplied by x to the 7th, because that's what's happening. Am I done yet? Well, no. We have like bases. Therefore, I can say 34 x to the 10th. Mr. H, where did you get x to the 10th? I added my 3 plus my 7, and that's where I got my 10. Bam. A little bit tougher. Use the distributive law to rewrite the expression in simpler form. This means I'm taking a times a. Distribute means multiply to everything. And then a times b. Well, that's a times a is a squared. Plus a times b, I cannot simplify. So that leaves me a squared plus ab. Okay? Where's different eraser? Okay. Last one with these, because why not? Exercise 20, I believe. Okay, so use the distributive law. Well, this is a binomial, two terms, bi meaning two, times a binomial. I will always split this. So now I have a times everything, I have b times everything. So a times a is a squared. A times b is ab. B times a is ab. Mr. H, why can it, if it's b times a, isn't that ba? The commutative property tells me that I can flip-flop them. And b times b is b squared. Another way that you could have done this is with this a, b, and you could have multiplied it using that kind of thing. I don't like the matrix method, but if you do, by all means. So now combine like terms. I have a squared plus, how many ab's do I have? Well, I have one ab plus another one ab. That's two ab's plus b squared. So even though we're distributing, we still need to know the exponent rules. How long has my video been so far? 12 minutes. No problems. Okay. Then it says, you know what? We've loved doing multiplication and we want to screw you up. Let's go to division. What? Why would it do that to us? Because Engaged New York expects a lot out of you. And if you know me, so do I. So I think you can certainly do this. So, if you've got the same base in both the numerator and denominator, you keep the base and you subtract the exponents. Plain and simple. Always the numerator from the denominator. Always. Keep the base. 9 minus 6 is 3. Keep the base. Remember, it's a fraction. Subtract 9 divided by 2. Or try this again. I'm sorry. I said 9 divided by 2. That was incorrect. It should be 9 minus 2 is 7. Let's move on. Let's do on your own. Try. $25 and 27. You can't quite see 27, but try 25 and 27. Okay, once you're back, you should have paused me, you should have worked on that. We keep the fraction in parentheses. 9 minus 2 is 7. There's nothing difficult about that at all, okay? 27 though, I don't even know what 27 says, let's see. I love this. I love this question because 2 to the 7th divided by 4 squared. Well, we can't simplify just that portion because they don't have the same bases. But what they did is they wrote it as 2 to the 4th. Why? Because 4 squared is 4 times 4, which is 2 times 2 times 2 times 2. Oh, that's how I got 2 to the 4th. Now, I can come back and say 2 to the 3rd. Love that question. Love, love, love that question. Okay, on your own, you are going to do, actually let's do this one together. We're going to do A together, and then you're going to do B and C on your own. So a together, if I write this, this is really 5 divided by x to the third, multiplied by 3x to the 8th, divided by what? Well, divided by 1. Why? Because every whole number or every integer has a denominator of 1. When we multiply fractions, we multiply directly across. 5 times 3 is 15, x to the 8th. Divided by x to the third times 1 is still x to the third. Do we have like bases? Hot dog, hot diggity dog. We keep the 15, we keep the base. 8 minus 3 is 5. I'd like you to do B and C the same way. So pause me, give B and C a try. Sad news, I'm out of Monster at this point. Okay, so as we rewrite this, I would start by writing it as a multiplication problem. 5x to the third multiplied by negative 4x to the sixth divided by 1. That leaves me negative 20. X to the sixth divided by, because remember we're multiplying across, positive times negative is negative, x to the third times 1 is x to the third. It leaves me negative 20, x to the third. And as always, I'm going to come back and check my answer because, you know, I've been known to be wrong. Last but not least, 5 divided by x to the third, multiplied by 11x to the fourth over 1. 55 x to the fourth over x to the third. That leaves me 55 x to the first. Do I need to have that 1 there? No. One of the keys, and this is why I like this problem, one of the keys to exponents is every term has an exponent. 55 is 55 to the first power. X is x to the first power. So this is the same as this, but when it's to the first power, we do not need to have that exponent there. So even though we get 55x to the first power, that really means 55 to the first power, x to the first power. The way we want to write it is with no exponents because they are ingrained in there saying that's an exponent. This is the same as saying, hey, if I show x, how many x's are there? Well, there's 1x. Do I always need to put a 1 there? No. The same idea holds true with exponents. Okay, shoot. Let's go to our problem set. Come on, problem set. Yeah, we're not doing anything else. You are doing numbers 3. You are doing number 3. All of number 3. So all of number 3. You are doing all of number 5. And number 4 is your extension question. I'm not going to lie and say number 4 is easy. It is not. It means that you have to read it, but you can certainly do it. I would give it a try. Okay? So 3 and 5 are must-dos. Number 4 you can do, and you'll be able to see the answers tomorrow. Shoo! Going to lesson 3 the next day.